Piaget, cognitive development. Basic principles of Piaget's theory. Jean Piaget, 1896 to 1980, earned his doctorate in biology in 1918 and began a program of research that has been called the Master Plan to address the question, how does knowledge develop? His theory of intellectual development, reflective of his basic interest in biology as well as knowledge, continues to spur research on the problem of how knowledge develops. Piaget postulated that human beings inherit two basic tendencies, organization and adaptation. Organization being the tendency to systematize and combine processes into coherent general systems, and adaptation, the tendency to adjust to the environment. For Piaget, these tendencies govern both physiological and mental functioning. Just as the biological process of digestion transforms food into a form that the body can use, so intellectual processes transform experiences into a form that the child can use in dealing with new situations. And just as biological processes must be kept in a state of balance through homeostasis, intellectual processes seek a balance through the process of equilibration, a form of self-regulation that all individuals use to bring coherence and stability to their conception of the world. Organization refers to the tendency of all individuals to systematize or combine processes into coherent systems, logically interrelated. When we think of tulips and roses as subcategories of the more general category flowers, instead of as two unrelated categories, we are using organization to aid our thinking process. This organizational capacity makes thinking processes efficient and powerful and allows a better fit or adaptation of the individual to the environment. Schemes. As children interact with their environment, parents, teachers, and age mates, they form organized, generalizable patterns of behavior or thought known as schemes, and these become the basis for understanding and adapting to the world in which they live. For the first 2 years or so, schemes are largely sensory and motor. Infants and toddlers learn about objects by putting them in their mouth, grasping them, and throwing them. During childhood, schemes are cognitive but concrete. A ball is a round object of various sizes, colors, and materials that can be bounced, thrown, hit, etc. During adolescence, schemes become more internal and abstract, imagining the structure of human DNA as a double helix. Adaptation. The process of creating a good fit or match between one's conception of reality, one's schemes, and the real-life experiences one encounters is called adaptation. According to Piaget, adaptation is accomplished by two sub-processes, assimilation and accommodation. A child may adapt by either interpreting an experience so that it fits an existing scheme, assimilation, or changing an existing scheme to incorporate the experience, accommodation. Imagine a 6-year-old who goes to an aquarium for the first time and calls the minnows little fish and the whales big fish. In both cases, the child is assimilating, attempting to fit a new experience into an existing scheme. In this case, the conception that all creatures that live in the water are fish. When her parents point out that even though whales live in the water, they are mammals, not fish, the 6-year-old begins to accommodate, to modify her existing scheme to fit the new experience she has encountered. Gradually, accommodations are made slowly over repeated experiences. A new scheme forms that contains non-fish creatures that live in the water. Relationships among organization, adaptation, and schemes. To give you a basic understanding of Piaget's ideas, we have talked about them as distinct elements, but the concepts are all related. In their drive to be organized, individuals try to have a place for everything, accommodation, so they can put everything in its place, assimilation. The product of organization and adaptation is the creation of new schemes that allow individuals to organize at a higher level and adapt more effectively. Equilibration, disequilibration, and learning. Piaget believed that people are driven to organize their schemes to achieve the best possible adaptation to their environment. He called this process equilibration. But what motivates people's drive toward equilibration? It is a state of disequilibration, or a perceived discrepancy between an existing scheme and something new. In other words, when people encounter something that is inconsistent with or contradicts what they already know or believe, this experience produces a disequilibration that they are driven to eliminate, assuming they are sufficiently interested in the new experience to begin with. A student may wonder why, for example, tomatoes and cucumbers are referred to as fruits in a science text, because she has always referred to them as vegetables and has distinguished fruits from vegetables on the basis of sweetness. This discrepancy may cause the student to read the text carefully or ask the teacher for explanation. Gradually, the student reorganizes her thinking about the classification of fruits and vegetables in terms of edible plant roots, stems, leaves, and ovaries so that it is more consistent with the expert view. These processes are two sides of the learning coin. For equilibration to occur, disequilibration must have already occurred. Disequilibration can occur spontaneously within an individual through maturation and experience, or it can be stimulated by someone else, such as a teacher. Another example of equilibration at work comes from the grandson of one of the authors who was 6 years old at the time. The daily routine that his mother took to and from their house past a cemetery in which there were a number of mausoleums. One day he asked what to him was a logical question given the nature of his schemes at the time. "Mommy, who lives in those little houses?" His mother then offered what she thought would be a simple and satisfactory explanation. "Those aren't houses, dear. They're places where dead people are buried." Rather than putting the matter to rest, her explanation created a state of disequilibration that resulted in several additional questions designed to create a new mental structure that would, albeit temporarily, bring his mental world back into balance. Over the next several days, he would ask such questions as, "If you're dead, does that mean you can't talk? If I touch their houses, will I die? Why do people die? And if I die, will you put me into one of those houses and get another little boy?" Answering these and other sensitive questions in an honest and satisfactory fashion is not an easy task and illustrates why teaching is such a challenging profession. Constructing knowledge. Meaningful learning, then, occurs when people create new ideas or knowledge, rules and hypotheses that explain things, from existing information. For example, facts, concepts, and procedures. To solve a problem, we have to search our memory for information that can be used to fashion a solution. Using information can mean experimenting, questioning, reflecting, discovering, inventing, and discussing. This process of creating knowledge to solve a problem and eliminate a disequilibration is referred to by Piagetian psychologists and educators as constructivism. It is a powerful notion that has motivated a great deal of psychological research that can be applied to teaching and learning. Constructivism will reappear in later chapters and in other forms. The pause and reflect features in each chapter are intended to stimulate constructivist thinking. Stages of cognitive development. Organization and adaptation are what Piaget called invariant structures or functions. Functions. This means that these thought processes function the same way for infants, children, adolescents, and adults. Schemes, however, are not invariant. They undergo systematic change at particular points in time. As a result, there are real differences between the ways younger children and older children think and between the ways children and adults think. The schemes of infants and toddlers, for example, are sensory and motor in nature. They are often referred to as habits or reflexes. In early childhood, schemes gradually become more mental in nature. During this period, they are called concepts or categories. Finally, by late adolescence or early adulthood, schemes are complex and result in what we call strategic or planful behavior. On the basis of his studies, Piaget concluded that schemes evolve through 4 stages. The rate at which a particular child proceeds through these stages varies, but Piaget believed the sequence is the same for all children. Piaget's 4 stages are described in the following sections. To help you grasp the sequence of these stages, Table 2.2 briefly outlines the age ranges to which they generally apply and their distinguishing characteristics. Stage sensory motor, birth to 2 years, develops schemes primarily through sense and motor activities, recognizes permanence of objects not seen. Pre-operational, 2 to 7 years, gradually acquires ability to conserve and decenter, but not capable of operations and unable to mentally reverse actions. Concrete operational, 7 to 11 years, capable of operations, but solves problems by generalizing from concrete experiences, not able to manipulate conditions mentally unless they have been experienced. Formal operational, 11 years and older, able to deal with abstractions, form hypotheses, solve problems systematically, engage in mental manipulations. Although Piaget used this stage or stair-step metaphor to describe the pattern of cognitive development, don't be misled into thinking that children jump from one stage to the next. In trying to understand certain concepts or solve certain problems, children may on some occasions use a more advanced kind of thinking, but on other occasions revert to an earlier, less sophisticated form. Over time, the more advanced concepts and strategies supplant the less sophisticated ones. Because of this variability in how children think, some developmental psychologists prefer to use the metaphor of overlapping waves rather than stages to characterize the nature of cognitive development. But because Piaget spoke in terms of stages, we will as well. Sensory motor stage, infants and toddlers. Up to the age of 2, children acquire understanding primarily through sensory impressions and motor activities. Therefore, Piaget called this the sensory-motor stage. Because infants are unable to move around much on their own during the first months of the postnatal existence, they develop schemes primarily by exploring their own bodies and senses. After toddlers learn to walk and manipulate things, however, they get into everything and build up a sizable repertoire of schemes involving external objects and situations. An important cognitive development milestone, object's permanence, occurs between the 4th and 8th months. Prior to this point, the phrase out of sight, out of mind is literally true. Infants treat objects that leave their field of vision as if they no longer exist. When they drop an object from their hands, or when an object at which they are looking is covered, for example, they do not search for it. As object permanence develops, children's intentional search behaviors become increasingly apparent. Most children under age 2 are able to use schemes they have mastered to engage in mental as well as physical trial and error behavior. By age 2, toddlers' schemes have become more mental in nature. You can see this in the way toddlers imitate the behavior of others. They imitate people they have not previously observed. They imitate the behavior of animals, and most important, they imitate even when the model is no longer present. This is called deferred imitation. These types of imitative behaviors show toddlers increasing ability to think in terms of symbols. Pre-operational stage, preschool and primary grades. The thinking of preschool and primary grade children, roughly 2 to 7 years old, centers on mastery of symbols, such as words, which permits them to benefit much more from past experiences. Piaget believed that many symbols are derived from mental imitation and involve both visual images and bodily sensations. Notice how the schemes of this stage incorporate and build on the schemes of the previous stage. Although the thinking at this stage is much more sophisticated than that of 1- and 2-year-olds, they can, for example, imitate the behavior of other people who are no longer present and engage in pretend play. Preschool children are limited in their ability to use their new symbol-oriented schemes. From an adult perspective, their thinking and behavior are illogical. When Piaget used the term operation, he meant an action carried out through logical thinking. Pre-operational then means pre-logical. The main impediments to logical thinking that preschoolers have to overcome are perceptual centration, irreversibility, and egocentrism. You can see these impediments at work most clearly when children attempt to solve conservation problems, those that test their ability to recognize that certain properties stay the same despite a change in appearance or position. One of the best-known conservation problems is conservation of continuous quantity. A child is taken to a quiet place by an experimenter who then pours water or juice or beans or whatever else into identical short glasses until the child agrees that each contains an equal amount. Then the water is poured from one of these glasses into a tall, thin glass, and the child is asked, "Is there more water in this glass?" The experimenter points to the tall glass, or this one, the short glass. Immediately after the child answers, the experimenter asks, "Why do you think so?" If the child's response is evasive or vague, the experimenter continues to probe until the child's underlying thought processes become clear. In carrying out this experiment, and many others similar to it, with children of different ages, Piaget discovered that children below the age of 6 or so maintain that there is more water in the tall, thin glass than in the short, squat glass. Although they agree at the beginning of the experiment that the water in the two identical glasses is equal, young children stoutly insist that after the water has been poured, the taller glass contains more. When asked, "Why do you think so?" many preschool children immediately and confidently reply, "Because it's taller." Children over the age of 6 or so, by contrast, are more likely to reply, "Well, it looks as if there's more water in this one because it's taller, but they're really the same." One reason pre-operational stage children have difficulty solving conservation problems, as well as other problems that require logical thinking, is perceptual centration, the strong tendency to focus attention on only one characteristic of an object or aspect of a problem or event at a time. Children focus on the height of the water in the two containers and ignore the differences in width because they lack the logical structures that allow them to coordinate these two dimensions. Another way to put this is to say that the child has not yet mastered decentration, the ability to think of more than one quality at a time, and is therefore not inclined to contemplate alternatives. The second impediment to logical thinking is irreversibility. This means that young children cannot mentally pour the water from the tall, thin glass back into the short, squat one, thereby proving to themselves that the glasses contain the same amount of water. For the same reason, these youngsters do not understand the logic behind simple mathematical reversals. 4 plus 5 equals 9. 9 take away 5 equals 4. The third major impediment is egocentrism. When applied to preschool children, egocentric does not mean selfish or conceited. It means that youngsters find it difficult, if not impossible, to take another person's point of view. In their conversations and experimental situations in which they are asked to describe how something would look if viewed by someone else, preschool children reveal that they often have difficulty seeing things from another person's perspective. They seem to assume that others see things the same way they see them. As a result, attempts to explain the logic behind conservation are usually met with quizzical looks and the insistence, some would mistakenly call it stubbornness, that the tall, thin glass contains more water. Concrete operational stage, elementary to early middle school. Through formal instruction, informal experiences, social contact, and maturation, children over the age of 7 gradually become less influenced by perceptual concentration, irreversibility, and egocentrism. Schemes are developing that allow a greater understanding of such logic-based tasks as conservation. Matter is neither created nor destroyed, but simply changes shape or form or position. Class inclusion, the construction of hierarchical relationships among related classes of items. And seriation, the arrangement of items in a particular order. But operational thinking is limited to objects that are actually present or that children have experienced concretely and directly. For this reason, Piaget described the stage from approximately 7 to 11 years as that of concrete operations. The nature of the concrete operational stage can be illustrated by the child's mastery of different kinds of conservation. By the age of 7, most children are able to explain correctly that water poured from a short, squat glass into a tall, thin glass is still the same amount of water. Being able to solve the water pouring problem, however, does not guarantee that a 7-year-old will be able to solve a similar problem involving 2 balls of clay. A child who has just explained why a tall glass of water contains the same amount as a short one may inconsistently maintain a few moments later that rolling one of 2 equally sized balls of clay into an elongated shape causes the rolled one to appear as if it contains more clay. Children in the primary and early elementary grades tend to react to each situation in terms of concrete experiences. The tendency to solve problems by generalizing from one situation to a similar situation does not occur with any degree of consistency until the end of the elementary school years. Nevertheless, children in the concrete operational stage are often more capable of learning advanced concepts than most people realize. According to the National Research Council, for example, the fundamental abilities that elementary students are expected to acquire include asking questions about objects, conducting simple observations, using simple equipment, such as a magnifying glass, to gather data and extend the senses, and constructing and communicating explanations. Pause and reflect. From Piaget's point of view, why is it incorrect to think of children as small adults? Formal operational stage, middle school, high school, and beyond. When children do reach the point of being able to generalize and engage in mental trial and error by thinking up hypotheses and testing them in their heads, they are at the stage of formal operations, according to Piaget. The term formal reflects the ability to respond to the form of a problem rather than its content and to form hypotheses. For example, the formal operational thinker can read the analogies 5 is to 15 as 1 is to 3, and penny is to dollar as year is to century, and realize that despite the different content, the form of the 2 problems is identical. Both analogies are based on ratios. In the same way, the formal thinker can understand and use complex language forms, proverbs, strike while the iron is hot, metaphors, procrastination is the thief of time, sarcasm, and satire. We can see the nature of formal operational thinking and how it differs from concrete thinking by looking at a simplified version of Piaget's rod-bending experiment. Adolescents are given a basin filled with water, a set of metal rods of varying lengths, and a set of weights. The rods are attached to the edge of the basin, and the weights to the ends of the rods. The subject's task is to figure out how much weight is required to bend a rod just enough to touch the water. Let's say that our hypothetical subject picks out the longest rod in the set, which is 9 inches long, attaches it to the edge of the basin, and puts just enough weight on one end of it to get it to touch the water. This observation is then recorded. Successively, shorter rods are selected, and the same procedure is carried out. At some point, the subject comes to the 4-inch rod. This rod does not touch the water, even when all of the weights have been attached to it. There are, however, 3 more rods, all of which are shorter than the last one tested. This is where the formal and concrete operators part company. The formal operational thinker reasons that if all of the available weights are not sufficient to bend the 4-inch rod enough to touch the water, the same will be true of the remaining rods. In essence, the rest of the experiment is done mentally and symbolically. The concrete operational thinker, however, continues trying out each rod and recording each observation independent of the others. Although both subjects reach the same conclusion, the formal operator does so through a more powerful and efficient process. But remember that new schemes develop gradually. Although adolescents can sometimes deal with mental abstractions representing concrete objects, most 12-year-olds solve problems haphazardly, using trial and error. It is not until the end of the high school years that adolescents are likely to approach a problem by forming hypotheses, mentally sorting out solutions, and systematically testing the most promising leads. Some Piaget scholars note that a significant aspect of formal thought is that it causes the adolescent to concentrate more on possibilities than on realities. This is the ability that Erikson and others suggest is instrumental in the emergence of the identity crisis. At the point when older adolescents can become aware of all the factors that have to be considered in choosing a career and can imagine what it might be like to be employed, some may feel so threatened and confused that they postpone the final choice. Yet the same capability can also help resolve the identity crisis because adolescents can reason about possibilities in a logical manner. An adolescent girl, for example, may consider working as a pediatrician, teacher, or child psychologist in the underprivileged environment because she has always enjoyed and sought out activities that allowed her to interact with children and has also been concerned with the effects of deprivation on development. Although mastery of formal thought equips some older adolescents with impressive intellectual skills, they may, as we noted earlier, take this newfound capability to extreme levels. The formal thinker now realizes that the present state of reality is just one of numerous possibilities. As a result, adolescents will often stridently argue that if an alternative is logically possible and superior to what exists, it should be implemented. They tend to have little patience, for example, for the adult who says, yes, it's unfortunate that some people are the target of unfair discrimination, but you can't legislate morality for a variety of practical reasons. Their response is likely to be not just that you can legislate morality, but that you should. This inability to differentiate between the world as the adolescent thinks it should be and the world as it actually is was referred to by David Elkind as adolescent egocentrism. This occurs when high school students use their emerging formal operational capabilities to think about themselves and the thinking of others. Because adolescents are preoccupied with themselves and how they appear to others, they assume that peers and adults are equally interested in what they think and do. This is why, in Elkin's view, the typical adolescent is so self-conscious. The major difference between the egocentrism of childhood and that of adolescent is summed up in Elkin's observation. The child is egocentric in the sense that he is unable to take another person's point of view. The adolescent, on the other hand, takes the other person's point of view to an extreme degree. Elkind believes that adolescent egocentrism also explains why the peer group becomes such a potent force in high school. Adolescent egocentrism accounts in part for the power of the peer group during this period. The adolescent is so concerned with the reactions of others toward him, particularly his peers, that he is willing to do many things which are opposed to all of his previous training and to his own best interests. At the same time, this egocentric impression that he is always on stage may help to account for the many and varied adolescent attention-getting maneuvers. Although the concept of adolescent egocentrism is widely accepted among researchers, ascribing its cause to formal operational thinking gets mixed support. Some studies have found a relationship, while other studies have not.